Hello students, welcome to Aerospace Engineering Lecture 1. In this particular lecture we will be talking about the liquid propulsion systems which has been used in rockets from many years. Please keep it in your mind that this video does not cover the propulsion mechanism of missiles. Like at the first sight it seems like the missiles uses same propulsion systems as rocket uses, but that's not true. Missiles uses jet propulsion systems, and we'll discuss that topic in another lecture. For this particular one, this is highly concentrated on understanding the mechanism and the principles of liquid propulsion systems of rockets which is used. So let's get into the video. Liquid propulsion system, as it has a name of liquid, so there's a question that arises that is rocket gonna use the normal diesel or petroleum that we use in our daily life vehicles, on road vehicles, because petroleum and diesels are in the form of liquid, and that's what we know about the fuel, the liquid fuel, right? No, like we have studied these things in our class 8th and ninth textbooks that rocket uses hydrogen. Yes, it uses hydrogen, and we also know that hydrogen is naturally find as gaseous state, its gaseous state, right? But again, here comes the basic physics concept of class 9th and 8th, and that is when we compress gas too much it becomes liquid, it liquefies. So same thing happened to the hydrogen here. Hydrogen is compressed into a special type of container which is also known as the fuel tank or the H2O tank of the rocket systems. So I will be drawing the diagrams for the better understanding like how the mechanism is loaded on the rocket. Maybe the demonstration, maybe the diagram will be not perfect, but yeah, that's a thing that you can use to make you understand. So this is the H2 tank, which is loaded with the liquid hydrogen because we have compressed hydrogen gas into this tank. Then here comes another, the class 9th and 10th physics aspect, that is combustion requires oxygen, right? So when a rocket leaves the atmosphere of earth and when it reaches the exosphere does not have any oxygen requirement, oxygen supplies, right? And there are many reasons about carrying rocket's own oxidizer with it. So as an oxidizer, rocket uses liquid oxygen. Same here, oxygen is found naturally in its gaseous state, but it is further converted into liquid by compressing it into a special tank, that is obviously the oxygen cylinder. Now these two tanks are loaded: liquid hydrogen tank, liquid oxygen tank. We'll mark these up. This liquid hydrogen is a fuel, is the main fuel, and this particular thing you see is an oxidizer, because in outer space we don't have any oxygen supplies, and hydrogen is very inflammable as we know, but it also requires oxygen. So now I hope you understand that why this propulsion mechanism is known as liquid propulsion system, because it comprises of liquid states of both the elements, the H2O and H2 and O2, right? Now these two containers are placed separately, right? So they are eventually mixed in the combustion chamber of the rocket. There's a part in the rocket body that is known as combustion chamber where the combustion actually take place. So what happens is there are pipelines which I'm gonna draw. So this is the pipeline you see from the liquid hydrogen tank. The flow of liquid hydrogen will be like this, right? Here is something special, that is the pump. I cannot draw the pump, but you just understand that there is a pump of H2O module. Pump basically allows the hydrogen to control the flow of liquid hydrogen, right? So we can eventually, by controlling the flow of liquid hydrogen, we can control the combustion ratio, and by doing that, we can control the speed of the rocket, right? So yeah, that pump is electrically operated, and every container, this H2 has its own pump and the O2 has its own pump. So I'm marking here pump H2. So this will be the pipeline and the flow of liquid oxygen towards the combustion chamber. And now one more special thing, and that is there is an intuition and there is a special kind of technique which is used. So first let's talk about the technique, and the technique is the both are fired at a specific angle, so the flow of hydrogen, liquid hydrogen, and the flow of liquid oxygen intersect each other at 90 degrees. By doing that, it eventually mixes and breaks down into smaller simpler pieces, like smaller simpler droplets of liquid hydrogen and liquid oxygen. And yet that does not mix water, because like just mixing them, like mixing of hydrogen and oxygen does not make water, right? So most of you guys will intuit that why there is no forming of water, because there is no energy, external energy is not provided here. It will be provided, and there are more intuitions that will be cleared you. So yeah, just keep watching. So I've drawn more. So now this particular thing is now looking like rocket, right? So this is the rocket nozzle, and before understanding why this rocket nozzle, we just first understand how the thrust is generated. Like we have seen Diwali rockets, like they use solid propellant technique, or you can say the powdered propellant technique. So they just burn, and the gases, the pressurized gases which is formed inside the body, is excreted out from a small hole. And because that so much pressure is just exerted by that tiny hole, it creates a lot of thrust, the perpendicular force, right? So that's how rocket lifts up. Same happens here. You see the combustion chamber has a spark plugs. Like I have drawn a spark plugs. If you zoom in a little bit you will see, but yeah, like just understand that the spark plugs are the instruments which you use to create a spark, right? So this spark basically ignites the hydrogen, and oxygen definitely supports it, and the pressure of the ignition, like when it is liquid, the hydrogen is in its liquid form, and when it is burned, it is provided extra energy, then obviously it will expand very vigorously. And when it is expanding, obviously it is pressurizing the inner body of the combustion chamber, and this combustion chamber have very tiny opening towards the rocket nozzle. So the same concept which is used in Diwali rockets is again applied here technically, and that generates lots of thrust, right? Because this tiny hole is supposed to excrete all the pressures which is built in the combustion chamber, right? You know, perfectly calculated like how much pressure this combustion chamber can tolerate. According to that, the diameter of the opening to its nozzle is decided, and there are so much calculations. So yeah, For basic understanding, you just learn theoretically, but at the practicality, you just see the differences. Like if the pressure of the combustion chamber is like very much and is not controllable by the hole, it will eventually burst off, right? So that's how rockets are getting blast, right? Because a single calculation mistake can lead to destruction, right? So that's how the thing is managed. So these combustion chamber have uh, spark plugs which creates sparks and ignites the fuel. And yes, the oxygen is used in the both of the cases, like when the rocket is in the Earth's atmosphere and when the rocket is leaving the Earth's atmosphere. This is because to perform a stable flight performance, like if we depend upon the nature's or atmospheric oxygen supplies, so the supply will not be constant, because when the altitude of the rocket will increase, the atmosphere gets thinner and thinner and the oxygen supplies get lesser. So the ratio of fuel combustion is not matched, and that's why the performance will be unstable. So to make that performance stable, we provide constant oxygen. So rocket uses oxygen in the atmosphere of the Earth, right? So yeah, don't think that we just use oxygen in the outer space. So we can, eventually uh, lesser our expenses on rockets. Like we will load lesser amount of oxidizers. That's not true because we need stable flight performance, right? That's why we use oxygen in the atmosphere for the constant supply and the constant stable performance of the flight. Okay, so I've written that these are not the gases, these are the pressurized H2O, and this particular thing is a sign of gaseous form of H2O, that is water vapor. And yes, guys, this liquid propulsion system is eco-friendly. Like it does not produces smoke as our car and road vehicles produces. Like you have seen some of the rocket launches, you see that there are heavy smokes are produced. It's like the cloud is forming on the land. Those are basically very highly pressurized water vapors, and yes, those are water vapors, right? So it is non-polluting. So this method is very eco-friendly, and that's why it's widely used in the rocket system. Eventually these pressurized gases create thrust which lifts up the rocket, and that's how the rocket propagates towards the sky. This is just the propulsion mechanism, the physical, you can consider this because there are more over in the propulsion mechanism. Like we use IMU as inertial measurement unit. Like this thrust is controlled by a computer or navigation system of the rocket, which is loaded beside the payload of the rocket, and that basically controls the thrust, like how much does it requires to lift up from the earth, like how much thrust does the rocket requires to tilt 15 degrees towards north. So yeah, that particular calculations is done by the computer, which has been inbuilt in the navigation system of the rocket bodies. So let me remind everything that in the rockets we use liquid hydrogen and liquid oxygen. Liquid hydrogen because it is very inflammable, and hydrogen is one of the cheapest fuels that we can use in rockets, right? Liquid oxygen because of we need oxygen supplies, the constant oxygen supply, and also the oxygen supply in the outer space. There are two reasons, not a single reason that vacuum does not have oxygen, that's why we are carrying this. It also requires because of a stable flight performance, like the flight needs a constant rate of oxygen, right? During the combustion session, that's why we don't depend upon the atmospheric oxygen. Instead of that, we carry our own oxygen tank. Yeah. Then these two tanks are connected with pipelines, with their pipelines, like they are not mixed on its own in the containers. They are mixed in the combustion chamber, like they are fired at certain angle, so they intersect. Their flow intersect each other at 90 degrees, and they're sprinkled. They perform like they're sprinkled into the combustion chamber, and Eventually, the spark plugs, which are present in the combustion chamber, ignites the fuel, and the fuel expands, and that pressurized gases escape from these tiny ore, which creates lots of force, and that force is perpendicular to the ground, and that is thrust, right? One thing I haven't mentioned, that there's a pump of oxygen itself. Yes, they both are controlled, and they are not mixed in the uh, container itself. So yeah, just keep it in your mind. This was the basic mechanism, the physical mechanism, you can say, about the propulsion system. Like, for a propulsion engineer, this particular thing he would be doing with the liquid propulsion system, but this is not the fully, functioning, ready to launch system, because it also requires some IMU integrations. So the rocket itself identifies like how much thrust it requires, how much fuel does it allows from the pumps to enter the combustion chamber. Like, there are many aspects regarding to the liquid propulsion systems also, but for a basic mechanism, like how rockets are lifting themselves in the skies, like big rockets, which is used in space missions. So these are the basic fundamentals of liquid propulsion system. And that's all for the lecture one. In the second lecture, we will be discussing about how the IMU integration works in the liquid propulsion system, or maybe we will be talking upon the propulsion systems of missiles, like how scramjet, ramjets, and turbojets works. And yeah, so there are many interesting chapters are incoming. So please be tuned. And also, that's for today's video. Thank you so much for watching. Keep studying well. Jai Hind.